All right. So now we are ready for part 2 of your changes of state of matter information. So if you look at your notes pages, you see it says points. Now, I think I updated your notes and I don't have a copy of that at home, but the points are the temperature at which the phase change happens. So I'm not real sure, I guess, is what I'm telling you, how you are seeing this, but the information is on there. We are talking about melting points, boiling points, condensation points, vaporization points, any of those that we had on the board when we did part 1 of this. And it says those points are just the temperature at which that phase change happens. And it asks you which 2 points are the same, and we're going to come back and look at that in a second. You also have at the bottom there, indo, and it says it's a prefix meaning in or into, like endothelial, that is your inner skin. Exo is a prefix that means out of or exit. That one should be easy to remember. And the root word therm means heat, like thermal underwear or isotherms on a weather map. Okay, therm is going to mean heat. Also somewhere there, if it's not written down, I would like you to add evaporation and boiling. I'm not sure if I've already added that or if you're going to have to write that into your notes yourself. I want you to understand that evaporation happens from the surface of a liquid and boiling happens throughout the liquid. Not great science, but as a visual, I think it's good. You go home and you boil water to make some macaroni and cheese. Where do you see the bubbles starting to boil or to bubble? You see it coming from the bottom, and it goes all the way throughout the liquid, where evaporation just happens from the surface. The top layer of water molecules come in contact with the bottom layer of the atmosphere, and that's what goes from a liquid to a gas state. So here, I guess what you need to remember is you need to look at the location. And remember, evaporation with an E is not vaporization. That's not a change of state. It's part of that, but the change of state is called vaporization, okay? So if you look on your graphic organizer page again, your second chart, the first column has changes of state. In the middle column, you have endothermic or exothermic. And in the third column, you have absorbed energy or release energy. And we are going to go through those 6 changes of state, and we are going to decide if it is an endothermic reaction, an exothermic reaction, if energy is coming into the system or going away from the system. If you can memorize this, more power to you. I can't do that. But I do know I can remember how the molecules move. And if I can remember how the molecules move, then I can figure out all of the answers to these charts. And I would be able to do anything in terms of answering questions on an achievement test. Okay? So, let's look here. First, I'm not going to write them totally out. We're going to do melting and freezing. Now, melting. So let's say that I am an ice cube, and I am sitting on a table, okay? Because I'm a solid, my molecules are just going to be vibrating in place. But as they take in heat energy from the surrounding environment, they're going to start moving a little bit faster and a little bit faster until they're going to be sliding past each other. Okay? They took in energy. if they took in energy to move faster, it is an endothermic reaction. Okay, maybe I should break that out. And so I'm just going to put a big N there for endothermic reaction. We had to take energy into the system so that they could move faster. Just like if you want to have more energy, you eat more food or sugar or carbs or whatever, and you get more energy, and then you're able to move faster. So, did we have to absorb energy to do that, or did we have to release energy to do that? We had to absorb energy, and I think the directions there tell you can just put an N or an X, or an A or an R for absorb or release energy, okay? So, our second one is freezing. Okay, so we are going to make ice cream. So we put all of our ingredients together and we have this liquid. And the liquid molecules are sliding past each other, okay? We put it in we lower the temperature so that the molecules start moving slower and slower and slower until they are just vibrating in place. Once they are all just vibrating in place, then they become a solid. So, to go from this state to this state, they had to get rid of energy. So, energy had to exit the system. It was an exothermic reaction. So that means they had to release energy. Okay? Change colors here again. So, next we have vaporization. And we have condensation. So, vaporization, that's when you go from a liquid to a gas. So you have molecules that are sliding past each other. Okay, they're sliding past each other. And then they start bouncing off the walls. They take in energy and start moving faster. If they're taking in energy, it is an endothermic reaction, and they had to absorb energy to do that. Condensation is the opposite. You have water molecules or whatever molecules bouncing off the walls of their container at each other. Energy leaves the system because it's starting to cool down. Heat energy is transferred out, and instead of bouncing off the walls, they start just sliding past each other. When that happens, they go from a gas to a liquid. It's an exothermic reaction, and they had to release energy for that to happen. The last two are sublimation and deposition. So sublimation is when we go directly from a solid to a gas. So you have molecules that are just vibrating in place, and then they start bouncing off the walls of their container. They have more energy. So it's an endothermic reaction because they had to take energy in. That means they had to absorb the energy. Okay? And then deposition is the opposite. You go from a gaseous state directly to a solid state. So instead of bouncing off the walls of their container and each other, they are now just vibrating in place. So they had to get rid of that excess energy because now they're moving slower. So it's an exothermic reaction. The energy exited the system. And that is, they had to release energy. All right? So I think that does it for part 2 of states of matter and their changes.